Hi, welcome to the tutorial on data exploration target variable part 2. Now by the end of this tutorial, you will be able to explain what an outlier is, identify outliers mathematically, create a box and a whisker plot in Python to identify outliers. First, let's understand what an outlier is. An outlier is a data point that is distant from the other data points. Its value lies outside the usual range of rest of the values in the data, and hence the term outlier. For better understanding, let's plot a scatter plot for our target variable sale price with row IDs on x-axis. For that, we write the code, and also we must remember to import the matplotlib library before plotting the graph. Type import matplotlib.py plot as plt. plt.scatterx equal to raw housing data id, comma y equal to raw housing data sale price. This scatter plot is nothing but the visual representation of all the values of the sale price variable in our dataset, where each dot represents a data point for sale price. From the graph, you can see that some data points are quite distant from the rest of the data points, so looks like this variable contains some outliers. It is important to note that outliers need not mean only usually high values. If there are data points which have much lower value than the rest, those are also outliers, though we are not able to see any such outliers in our graph at the moment. Also, there could be data points whose absolute values are within the range, but when viewed in context of other information or variable, that data point may be an outlier. For example, let's say hypothetically, if the scatter plot between two variables, say x and y, came out as shown on the screen. Now as you can see, the absolute value of this data point with value 3000 is within the range of the overall values for y variable, which ranges between 0 to 5000. However, it is still an outlier as it is distant from rest of the data points with similar values of the x variable. So remember that in the strictest sense, outlier means a data point that is distant from rest of the observations. Though in this training, we would be looking at only those outliers whose values are very different when compared with the rest of the data points of the same variable itself and not in context of another variable. Now as we have learnt earlier, in any observation which falls far away from our data point is termed as outlier. But the question is, how much far? Let's answer this mathematically so that we have a precise method or formula to identify outliers. We have learned quartiles and interquartiles range earlier, and we would use that knowledge in creating the formula. Let's look at the first quartile or the 25th percentile value and third quartile or the 75th percentile value for our variable sale price. These values will be the same which we have obtained in our output of descriptive statistics as shown on the screen. Now as we can see, the 25th percentile value is 321,950 and 75th percentile value is 645,000. We also see the current minimum value is 75,000 and current maximum value is 7,700,000. The interquartile range or the IQR is the difference between the 75th percentile and the 25th percentile, that is 323,050. Now let's define two new variables, lower limit and upper limit, as shown on the screen. Lower limit is equal to Q1 minus 1.5 into IQR is equal to 321,950 minus 1.5 into 323,050 is equal to minus 162,625. Upper limit is equal to Q3 plus 1.5 into IQR equal to 645,000 plus 1.5 into 323,050 equal to 1,129,575. Now we see that the lower limit comes out to be lower than the minimum value, and since we would not have any data point in our dataset lower than the minimum value, it would make sense to restrict the lower limit to minimum value. So let's redefine the lower limit, which will be lower limit equal to minimum of raw housing data sale price equal to 75,000. On the other hand, we see that the upper limit is 1,129,575, which is lower than the maximum value of sale price of 7.7 million and hence is okay. Had the upper limit come out to be higher than the maximum value, we would have restricted that also to the maximum value. Any data point which is higher than the upper limit or lower than the lower limit can be termed as an outlier. Now as you can see, our lower limit is same as the minimum value of the sale price in the dataset, and hence we would not have any data point which are lower than this, and hence there are no outliers which have unusually low values as we had seen in the scatter plot also. However, value of upper limit comes out to be 1,129,575 or approximately 1.13 million, while the maximum value for sale price in our dataset is 7.7 million, and all the data points between upper limit and maximum value, including both, can be termed outliers. So, there are outliers with unusually high values as we had seen in the scatter plot also. Now it will be easier to understand all of this in a box and whisker plot as shown here. As we can see in the chart above, all the data points beyond upper limit can be termed as outliers. Here is a question for you now. Go back to the high value observations we had seen while eyeballing the top 10 and the last 10 rows and decide which of those can be termed outliers and why. Let's learn how we can create a box and whisker plot like one we just saw, which helps us identify outliers in Python. For that, we will not be using the matplotlib library because this library doesn't have the capability to ignore the missing values for the variable, and we know that our variable sale price has 4 missing values that we are yet to treat. So, we will use another library called the Seaborn library, which has the capability to ignore the missing values and create the box plots easily. For this library, we do not have to install, as it comes as a default library for Jupyter Notebook. We just have to import our program and use it. Let's import the Seaborn library. We type import Seaborn as SNS. Next, we write the code for building the text plot graph sns.boxplot x equal to raw housing data sale price. Now as you can see, this box plot graph is similar to the one we drew previously and shows outliers. So that's it in this tutorial. In the next tutorial, we will discuss why outliers occur and how do they cause problems in analysis and modeling. See you there.